10.5, 10.6 area parallelograms and trapezoids, rhombuses, and heights. I can find the area and missing dimensions of parallelograms, trapezoids, rhombuses, and heights.
Cody, thank you. Your mom will be very proud of you. Right, you guys?
Yes.
Very proud of you. All right, ladies and gentlemen, area would be something, or the space inside of a shape. It's the number of boxes, square boxes we can put in a shape, right?
Yes.
Yes or no?
Yes.
Okay, this is your video. I want your eyes on me, okay? Eyes on me, or eyes on the screen. Parallelogram. Can you identify a parallelogram?
Yes.
Its name says it all. Opposite sides are? And they're also? Congruent. Cool. And rectangle. Yes, yes. We just did that for our congruence markers. Trapezoid. What are the bases of a trapezoid? Somebody tell me the bases of a trapezoid are always going to be what, Ava?
Parallel sides.
The parallel sides. Because a trapezoid only has one set of parallel sides. So in this trapezoid right here, base 1, base 2. Does it matter which one's base 1 or which one's base 2?
No.
Samatar, I said eyes up here. Your eyes are not up here. Rhombus. 4 congruent sides. Kite. Adjacent congruent sides. We got it? What's the area for a rhombus and kite? Is it any different? Are the formula to calculate the area of a rhombus and kite is the same or it's different? Which one?
Same.
We'll get to that in a second. Parallelograms. Are they any different than calculating the area of a square?
No.
Do we use this side of a parallelogram to calculate the area?
No.
The only good this is for would be for side length and then ultimately perimeter. Okay, it's height. So area equals base times height. This is the height. This would be one of your bases, or length times width, depending on how you look at it. Don't let that mess you up. They're going to definitely, on any test, try to get you to use that as one of the lengths to calculate area. You know better than that, right?
Yes.
You better. Now, the algebra. Let's just focus on number 9 because the rest of them are very similar. We have ourselves a rectangle here, yes or no?
Yes.
Okay? I gave you the area of this rectangle, yes or no?
Yes.
This is the area of the rectangle. I gave you the base, yes or no?
Yes. No. No.
Well, isn't this the base?
Yeah.
Did I give you the base?
No.
Did I give you the base?
No.
No, I didn't give you the base. I just gave you x. Did I give you the height? What is it? 4. So I've given you base. I'm not giving you base, but I have given you height. So we're going to plug in our numbers. Area is what?
36.
Base is what?
X.
Height is what?
4.
Do we have enough information to calculate the base?
Yes.
Can we use algebra?
Yes.
How do we get this x by itself? Well, because we're multiplying, how do you want to do multiplication? So what are we going to divide by?
4.
4, and what happens to the 4s?
That cancels out.
And if we divide this side by 4, we have to divide,
Yes.
well, this side by, the other side by 4, right? What's 36 divided by 4?
9.
So do we now know the base?
Yeah.
The base is?
9 inches.
Number 10, same problem, no picture. Number 11, same problem with a picture, except for that's, what kind of shape is that again? What kind of shape is that again? Everybody, what kind of shape is that?
Parallelogram.
Do we use this to calculate the height?
No.
That's just the side length, right?
Yeah.
Trapezoids, any issues with trapezoids?
No.
Okay, as we've talked about. Oops. See this formula right here? See this formula right here?
Yeah.
Do they look different?
Yes.
Do they look different?
Yes.
Are they different?
Yes. No.
No, they're the same thing, it's just written in a different way. Area of a kite. What's the area of a kite? What's the area of a kite? So, Ilana.
Diagonal 1 times diagonal 2 divided by 2.
Is this also the area of a kite?
Yes.
Does it matter which one you use?
No.
You're going to get to the same answer, aren't you? So what is the diagonal? What is the diagonal? Aryan. So from green to green here, from green to green, from green vertex to green vertex, is that a diagonal?
Yeah.
Because they are
Non-consecutive.
non-consecutive vertices. Are we all involved here?
Yes.
I don't look like it doesn't look like you're all involved. From this to this, are these non-consecutive vertices? No, they're connected. That just makes up a side or an edge, right? Okay, so now that we know what diagonals are, Can we calculate the area of a kite or a rhombus?
Yes. Yes.
So it looks like it's telling us this diagonal right there is what?
10 meters.
10 meters. This diagonal right here is what?
9.
So if we plug it into our formula, either of our formulas, they're both the same, what are we going to get? 45 meters squared. I challenge you. I'm not going to do this on the video. I challenge you to understand what we did here on letter B to calculate our missing dimensions and our diagonals using Pythagorean theorem. This is not required, but I will probably shoot something like that to you on the test.